Hello my friends, I'm Clover and this is Gas. So today we're solving a disjoint group Sudoku by Philip Newman. It's called Strider and it was originally posted on December 25th, 2024. This is his Christmas Day puzzle. And how does this work? So we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And then the other constraint we have is called disjoint groups. And what that means is if you look at the positions within each region, so first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, two digits that are in the same position in two different regions. So for instance, these digits are in the same position in their regions, and then like these digits are in the same position in their regions, these digits, etc. So any of those pairs of digits can't ever be the same. So because there's a 1 in the top middle of this region, for example, there can't be a 1 in the top middle of any other region in the entire grid. This is a notoriously difficult variant to get your head around, especially when you run into a harder one, but knowing Philip, I am sure he has made this at least relatively approachable for us, so let's have a look at it. So we have a lot of center cells already. We have 2, 4, 6, and 8, and we also have 5. So we can't use any of those digits in any of the other center cells of any regions in the entire grid. So the only remaining digits for those are 1, 3, 7, and 9. And we can make some eliminations based on what's already in the regions. But that doesn't quite give us enough information to actually narrow things down yet. So let's see what else we've been given. We have a couple of top center digits, 1, 2, and 3 here. We have a 1 there and there, so we know 1 is in one of those two cells. We actually have quite a few 1s, and I'm wondering if that's maybe where I'm intended to start with this. So 1's there and there. 1 can't go in that cell because of the disjoint constraint, so 1 is in one of those. I'm not totally sure that that's where I'm meant to be starting here. Let's see. Am I missing a possible elimination that I could be making? With these cells, I'm not sure that I am. I mean, I need to place a 4 and a 6 in here. There's not really any restriction on that. Oh, this is tricky. I'm not seeing where to get started with this one, and as you can probably tell, I haven't tested this one previous to trying to solve this on video. But we're gonna figure it out, guys. So one of these guys has to be a 3. One of those has to be a 1. One of those has to be a 1. I don't think this is the approach that Philip would have wanted us to take. This seems like it's going to take a lot of very fussy counting. And I'm not sure that that is how we are meant to be looking at this. So 2 there. We have some cells that are on the right side of their region, 3, 6, and 9. We have some cells that are on the left side of their region. We have some cells that are... I'm not sure. So let's just start with 1s and let's go from there and let's see if we can work this out. So we have 1s in 3 of the possible positions. So we also need to put a 1. So I'm noticing now that we have 2 1s that are in the top row of their region. And we need to put a 1 in the top left of its region somewhere. And so it can't go in the top left in this row, it can't go in the top left in this row, so it would have to go up here. But there's a 7 blocking it there, so the 1 must go there. That's where we're going to put a 1 in the top left. And that, with a little Sudoku, gives us a 1 here in this region. That's the only position it can go in the bottom left region. That makes this a 3, and that is actually going to get us unstuck, which makes me think that's what Philip wanted us to look at. Now that has to be a 1 by Sudoku. Okay, that's a good start. So now can we do something similar with 9s? We have these 9s placed already. So we definitely need to put a 9 in the bottom right of its region. And again, the reason I'm kind of fixating on that particular location is because I already have a 9 in the bottom left and a 9 in the bottom center. So where can I put a 9 in the bottom right? That's going to be pretty limited. Can't go there because there's a 3 there already, so it has to go here. And that will let me place a 9 in this cell. Now I can place a 9 right here. Oh, and I notice now I have these two 1s and this one that places a 1 there. And I have these two 9s and that 9, which places a 9 there. And now I also, this is the only position for 9 in this region, and this is the only position for 1 in this region. Nice. Now these rows are looking really close to being complete. That has to be 2, 5, 6. This can't be a 6 because there's a 6 right there, and then also because this 6 is in the center right position, that rules out this 6 too, so that has to be a 6. And now symmetrically, these have to be 4, 5, 8. There's a 4 in the center left position, so 4 can't be in these two center left positions, so 4 has to be there. Vertically here, we need 2, 3, 4, and 5. Now this, I see this can't be a 2 or 3 because we've already used 2 and 3 in the top center, so that will be a 4, 5 pair. And then this, of course, can't be a 3, so that's my 2 and that's my 3. And then I have the 4, 5 pair there. And these will be 5, 6, 7, and 8. I already have a 7 and 8 in the bottom center, so I can eliminate 7 and 8 from these two bottom center positions, and then this will be a 7, 8 pair. But this can't be 7 because of the 7 right next to it, so that's an 8 and that's a 7, and that's the symmetrical deduction to the one we just made a moment ago. Now in this central column, the digits we still need are 4 and 6. We can't eliminate either of those yet. In the central row, we need 2, 3, 7, and 8. Okay, what have we already done? So in the center left position, we've already used 5, 7, 8, 4, 6, 1, and 9. So we've already used 7 and 8, so we can eliminate 7 and 8 from these cells. And therefore this one has to be a 2, and that's a 3. Now, this cannot be a 7 because we already have a 7 in the region. So there's an 8 there and a 7 there. Okay. Now we need to place a 7 in one of these cells. It can't go in the top left because of this 7 right there. So it goes right there. That can't... Oops, that is either a 5 or an 8, and my 4 goes there because there's a hidden 4 in this region. And that's going to resolve quite a bit via just ordinary Sudoku, so I'm going to follow up on all of that first before I do anything else. Now I need to place a 2 and 3 here. The 3 can't go up here, so it has to go right there. These will be 5 and 6. These will be 4 and 7 to finish the region. These will be 2 and 3. These will be 7 and 8. These are 4 and 5. These last two cells are 3 and 6, which resolve because we have a 6 in row 7 already. This row finishes with a 4. This row finishes with a 6. This row finishes with a 2, 5 pair. And we've already used a 2 in the top left corner right there, so that's a 5 and that's a 2. We've already used a 6 in the top right corner, so that's a 5, that's a 6, and that resolves this. These two digits have to be 6 and 8 to finish the row, and those resolve via normal Sudoku. Similarly, these have to be 2 and 4, and these have to be 5 and 8. Alright, so a little bit of a slow start, but I did really enjoy that one. That is called Strider by Philip Newman, and I hope you enjoyed it. If you want to check it out yourself, a link to do so is in the description below this video. And I will see you in 3 days.